Factor x squared minus 2xy plus y squared. Now, first of all, we notice that we have three terms. What are they? There's the first term, the second term, and the third term. And this is a very special what? Trinomial? Because you have a minus 2xy right here. You say, well, what makes that so special? Let me show you. First thing we notice about this, not only three terms, but we notice what? This is a square, and this is a square. In other words, x times x is x squared, and y times y is y squared. So the first and third terms are perfect squares, okay? Right? So because they're perfect squares, I want to say my terms are going to be x and y. Okay? Now the sign's going to be minus because I have a minus 2xy right there. But I want x times x, and I want y times y to give me x squared and y squared. Okay? The question is this a perfect number right here? Is this a perfect number right here? What are you talking about? Well, when you FOIL this thing, your outside terms are the x and the minus y. That's the outsides. FOIL. The insides are these two terms, aren't they? The minus y and the x are the inside terms. All right? And when you multiply the inside terms, you get minus 1xy. Multiply the outside terms. What do you mean the outsides? I'm talking about the x here and the what? The minus y. When you multiply your outside terms, you get the same thing again. So because you're getting the same thing again, when you add them, what's minus 1 and minus 1? Because this is minus 1xy. Minus 1 and minus 1 is a minus 2, and that's perfect. Okay? If you end up where this term is this term, then this is a perfect square trinomial. Okay? It's a trinomial where you have a perfect square. Now, one day when I was teaching this, somebody told me, Mr. Bump, that looks like a smiley face. And because I got the same number here that I got here, indeed, that thing really does smile at you. So, we can write this twice, or I can write it with a perfect what? What's that little 2 called? Square? Huh? Okay, so because this negative 2 is the same as this negative 2, we have a perfect square trinomial. And so I like to draw a trinomial up here. 1, 2, 3 parts, 3 sides. One side I'll call x squared. The bottom side I'll say negative 2xy. This side I'll call y squared. And indeed, this trinomial became a what? A perfect what? Can you say the word square? Okay. So the trinomial became a square because I have a little 2 right here. It was a 3-part thing right there. Okay. X squared minus 2xy plus y squared. And it became a perfect square whose sides are what? X minus y. Let me put that for this side. And the other side is x minus y. Again, the length times the width gives you the trinomial. So the square becomes a trinomial. Okay. Now this works because one of the properties we had trinomial squares, that when you square this thing you get this, and when you square this thing you get this. This is the multiplication problem videos that we learned before. Okay. But the trinomial 1, 2, 3 becomes a perfect square. Call it trinomial square.